fundamental theorem of algebra is something that should, I always thought fundamental theorem should be like earth-shattering, and I was kind of a little disappointed because the fundamental theorem of algebra just says that every complex polynomial function of degree greater than or equal to 1 has at least one complex zero. And remember that a complex number is a real number or an imaginary number, right? That's the whole number system. Complex numbers, some are real, some are imaginary. They're all complex. So the fundamental theorem of algebra just says, hey, if you have a complex polynomial function, then it's going to have at least one zero, real or imaginary. That's not very exciting. But this is kind of the add-on to it. This is the really important part. Every complex polynomial function of degree greater than or equal to 1 has exactly n complex zeros. Some could be repeated zeros, so like -2 might count twice, but that's still counting the multiplicity. So if you have a degree 5 polynomial, you will have 5 total zeros. Some might be real, some might be imaginary, but you'll have 5 answers altogether. And until you talk about this, we always say it could have up to that many, but we've never said it has to have exactly that many because we've always thrown out the imaginary until today. The other little rule today, before we get started, is that imaginary numbers always come in pairs. So it says if f of x is a polynomial function with real coefficients, if a plus bi is a 0, then its conjugate a minus bi is also a 0. That is important because you can't have i's left in your polynomial at the end. So if I give you a polynomial function and I give you one imaginary 0, I don't have to give you the other one because you're going to automatically know that the other one exists. So let's see if the next example helps us with that. Okay, let's look at this. So it says a function of degree 5 has zeros 1, 5i, and 1 plus I. Find the remaining zeros. We know if it's degree 5, it has 5 total zeros, right? So 1 is a 0, 5i is a 0. If 5i is a 0, what else has to be a 0? Negative 5i. They're conjugates. If it's just a number, you just do the opposite. And if 1 plus I is a 0, what is the conjugate of 1 plus I? 1 minus I. So a couple things to pay attention to about conjugates. If there's no addition or subtraction, the conjugate is just the opposite. But if there's addition or subtraction, it's always just you change the middle sign. So 1 plus I is 1 minus I, so that when you FOIL it out, the i's all cancel out. So part of your homework today is that easy. You just have to put the ones that are missing. And does that equal 5 total zeros? They gave me 3. I found 2 more. Hooray. Okay, so remember how easy this is as we go into one that's not so easy, okay? Keep it balanced out. It says use the given 0 to find the remaining zeros. If I told you a 0 of 2 was in this problem, what would you do with 2 to figure out what remaining 0 was in there? Right, like what have we been doing when we find our zeros? Once we find 1, what do we do? Synthetically divide it out. Well, we're going to do the same thing only with imaginary zeros. Yes. So because I know 2i is a 0, I'm going to synthetically divide it out. So I'm going to, over here in my little box, I'm going to put 2i. And I'm going to bring down all my numbers. 1, negative 4, 4, negative 16. It goes down by 1, so I don't need to fill my zeros in. And remember, when you add numbers with i's, they have to have an I with it to add. Otherwise, you just have to put it together. Like 1 plus I, you can't put together. So when I bring this down and I get 1, and I take 1 times 2i, I cannot say negative 4 plus 2i is negative 2i. I have to just say that's negative 4 plus 2i. With me on that? Now I'm going to take this and multiply it by this. I call this my side work. I'm going to actually work it out over here. So I'm going to take 2i times negative 4 plus 2i, because that's what I'm going to write in the next spot. And 2i times negative 4 is negative 8i. And 2i times 2i is 4i squared. But what do we know about I squared? I squared equals negative 1, so this is really negative 8i minus 4. And if you can do that all in one step, I'm okay with it. I just wanted to remind you of the that I squared is really negative 1. So this is actually negative 8I minus 4. So 4 minus 4 is 0, so that's just negative 8I. And when I take negative 8I times 2I, I get negative 16I squared. But does that just give me 16? Which is a good thing. They told me it was a 0. I better get a remainder of 0. That does look so pretty with those i's left over. But we have that lovely conjugate theorem. If 2I is a 0, what else has to be a 0? Let's do it again with negative 2I. Remember how easy the last problem was? I may be putting this on your notes because there's one like this on your exam where you have to divide these out. So it's not something that we can just skip over. It's because they want you to be able to do this. The good thing is it should work out nice on this one. We should get the i's to cancel out because if you take a number and its conjugate out, there should be no imaginary part left. So the hard part is the first one, and then it should work out much nicer. Like 1 times negative 2I is negative 2I. So the i's cancel out, and I just get negative 4. And then negative 4 times negative 2I is 8I, which means I do get 0 left. And think about what the degree of our answer is going to be. This was x to the third. So when I divided 1 out, I got x squared. And I divide this out, it's just x to the first now. You agree with me on that? Because I take out, I go down by 1 degree and then by 1 degree again. So this is just x minus 4 left. And can I solve that? Yeah, I'm going to get set it equal to 0, and I just get x equals 4. And what does the directions say? Find the remaining zeros. So I could say negative 2I, I guess. I tend to write all 3 zeros. Like I like to say plus or minus 2I and 4. But if it just says find the remaining zeros, those are really what I'm looking for. But I would have marked it wrong if you gave me 2I also. Angel.
Wait, excuse me, I looked at the thing and like put one that's similar to the test in my notes. Because I want to know like how long I'm gonna need, how much I'm gonna need to do it. Because I feel like these take a while.
They do take a while. So let's look at the next one. It takes even longer, right? Tomorrow when we review, Angel, the review will be to give you a better idea of which types.
Okay.
So, we're going to do another one because the one we just did wasn't as bad as it can get because it didn't have addition in it. If what we're dividing by is 3 minus 2I, we're going to have to FOIL out with some i's, and it definitely takes some time. I believe there are only like 16 questions on your unit exam, and I think day 1, I'm going to give you 8 or 9 of those questions, which means you only have to do 8 or 9 questions in a whole class period because they do take a while. They do take time to do. The idea is know how to start them. Don't spend 5 minutes staring at it, not sure what to do. And then you just have to multiply correctly. So I'm going to do 3 minus 2I, 1, negative 6, 11, 12, negative 26. And definitely it's nice to have some side work. Oh, look at that lovely straight line, Andrew. Some paper to work this out because you are going to have to FOIL some stuff out. Good news is we know it should equal 0 at the end. Bad news, what if it doesn't equal 0 at the end and you're taking a test, right? My advice is move on and come back if you have time. Don't waste 30 minutes of a class on one question. When at least if you started it right, I can see where you messed up. So if I bring the 1 down, that's 1 step done. 1 times 3 minus 2I is 3 minus 2I. And I can't put the I with this, but I can say negative 6 plus 3 is negative 3 minus 2I. So the good news is I really only have 3 more spots to do, but I am going to have to do a good amount of work. I have to FOIL these, right? So I always work it out to the side because I don't want to make a silly mistake in my head. So over to the side, I'm going to write 3 minus 2I times negative 3 minus 2I. And I'm just going to FOIL, going to watch my signs, and I'm going to remember that I squared equals negative 1. So I'm going to get negative 9 minus 6I plus 6I plus 4I squared, but that's really going to turn into minus 4, right? That's plus 4I squared. Very easy to make a negative mistake, and what happens a lot is people will be like, it didn't work out, I need you to find my mistake. And I'm happy to do that on homework, but on a test I can't say, hey, go back and do this. All I can say is go back and retry, which is why I say if you don't get it to work out, to just move on. But I think this one works out. The middle cancels out, right? And we just get negative 13, which means this actually isn't so bad, because the next one we're not going to have to FOIL. 11 plus negative 13 is negative 2. And if I take negative 2 times that, I can do that without much work. Negative 2 times 3 is negative 6. And negative 2 times negative 2I is plus 4I. So I get 6 plus 4I. And some people just automatically put 26 there because they just know it's going to work. I tend to actually make sure it works, to make sure I didn't make a mistake. But I think it should work. If we take 6 plus 4I times 3 minus 2I, we get 18 minus 12I plus 12I, and that's minus 8I squared, which is going to become plus 8, which does give me positive 26. It gives me hope when I get 0 there that I've done the hardest part correctly. Because the next part, all the I parts should cancel out. You shouldn't have to FOIL anymore after this first part. So it is a long problem, but it's not completely impossible. There's just a lot of room for mistake. If 3 minus 2I is a 0, what else has to be a 0? 3 plus 2I, and again, the good news, maybe bad news, is that I know I should get 0 here. So if I don't get 0 here, I know I've done something wrong. No, you only change the sign of the middle one. So when I bring my 1 down, I get 3 plus 2I. Which gives me 0. Sorry, I was having a moment, because I forgot that 0 times this is 0. I was thinking that it was going to be 3 plus 2I here, and I was like, oh my gosh, it doesn't work. But 0 times 3 plus 2I is 0. That's the stupid mistakes I make. I end up writing 3 plus 2I here, and then I think it doesn't work. Negative 2 plus 0 is negative 2. And negative 2 times 3 plus 2I is negative 6 minus 4I, which does give me a remainder of 0. If you can get through that first step, it gets better. And again, watch your exponents. This was x to the 4th. If we divide out 2, we're now left with x squared. X squared plus 0x minus 2 equals 0. And what's left should be a quadratic or less that you can work out. You could do the quadratic formula here, but to me it makes sense to just add that 2 over and say x equals plus or minus the square root of 2. And I'm going to just write all the answers. X equals 3 plus or minus 2I. So this would be a problem that has 2 imaginary and 2 real answers. You don't have to write all the formulas. I will tell you, I'm 99% sure the one on your test is more like this than the one before. Like it has the addition in it.
I feel like this is easier than what we did last time.
Well, there you go. Well, we're going to do what we did last night too in a minute. So. But yeah, it is very much just step by step. It's just, the problem is there's just so much room for error. Like if you don't get 0 here, it's just frustrating. And let me tell you, I've been there.
Telling you the 0.
Right.
It's easy to know if you're doing it wrong.
Yeah, I agree. The only other thing we have to do is what we did yesterday, only including imaginary zeros. And the hard part is you do have to just guess those PRZs. The good thing about the unit exam is either the PRZs are very few, right? Like you only have maybe 4 to check, or they tell you some of them that don't work. Like there's one on your unit test that says find all zeros if 2 and 1/2 and -1 are not zeros, which means they're already telling you some of your PRZs don't work. So they're eliminating some of the options. So again, you don't have to spend 10 minutes checking all of them, which I found very nice. I was like, oh, I should do that when I give a test. Instead of being so mean and giving PRZs that work. So if I say find all the zeros, that includes imaginary zeros. It means there's no just crossing it out because it's imaginary. You might have to do the quadratic formula or complete the square and get imaginary solutions. Write in factored form. Again, that just means where you write it as factors. And I like to show you both ways because sometimes they ask you for the zeros and sometimes they ask you for the factors. This one's kind of not so great because there's a lot of PRZs, right? Like we could say factors of 18, oh my goodness, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18.
Oh my gosh. Okay.
All over factors of 3. So then you have to put everything over 3, so that's plus or minus 2/3, plus or minus. You don't have to restate these, right? 2 over 3 is 2/3, but 3 over 3 is 1. We already have it. 6 over 3 is 2. We already have it. 9 over 3 is 6. We already have it. 18. Sorry, 9 over 3 is 3, not 6. 18 over 3 is 6. So really, 2/3 is our only fraction. Do you agree with that statement? So that's not so bad, right? This would be terrible on a test. They would never give you one with this many PRCs.
But yeah, what about a third?
Oh, just kidding. 1/3. Oh, really 4, because one's positive and one's negative. Here's what I noticed right away. There's a whole lot of positives in this problem, right? Which means if I plug in any of these positive numbers, not counting fractions, that's just going to keep getting bigger. You see what I'm saying on that? So like if I plug 2 in here, that's just going to be big positive plus big positive minus 18. Without even checking, none of these positive whole numbers are going to work. Because it's not going to go to 0 when this is the only negative. So use that. Think about that. One of these fractions could work because fractions have, they could make things smaller. So we want to check a positive fraction or you want to check some negatives first? Did you get one to work already? Oh, let's go with it. Which one worked? So I'm telling you on your test, there are not this many PRZs that you have to check, so it shouldn't be this issue. But use your brain, use your common sense when you start checking numbers if you see that they're just getting really big or when you see all positives. Notice I didn't do Descartes' rule of signs, but I can tell just by looking that they only change once here, which means there is one positive real 0 for sure. I think we just found it. If I divide that out, 3, 5, 25, 45, negative 18. 3 times 1/3 is 1. 6 times 1/3 is 2. 27 times 1/3 is 9. 54 times 1/3 is 18. Oh, I should have just looked here. So nobody equals 0. And again, I kind of already see that I think I'm going to be able to do factor by grouping here. The other option is, look what happens when we write what's left. 3x squared plus 6, sorry, just kidding. It's not x squared, right? It's x to the 3rd because we start with x to the 4th. Plus 6x squared plus 27x plus 54. I don't know how to solve this by the quadratic formula or by factoring, which means you could just keep guessing. It means there has to be a -1 that works. Or you can do that factor by grouping. And when I look at this, it looks to me like I could factor something out of both of them, and there's a good chance that I might get that to factor by grouping. Great method if you notice it. It saves you a lot of time. Sometimes it's not going to work, but let's see if this works. If I factor a 3x out of this, I'm left with x squared plus 2. Is that true? 3, nope, sorry. I can factor out a 3x squared and be left with x plus 2. Yes, is that better? 27 goes into 54 2 times, right? So I can factor out a 27 and be left with x plus 2. Good news is if you didn't do this, negative 2 works. So if you start negative 1, negative 2, you're going to find that negative 2 works very quickly. But to me, factor by grouping is the fastest way to go because I can now write this as x plus 2 and 3x squared plus 2. Shit. I know. My kid did this last night, and I got observed first hour, and everybody asked me questions I didn't know how to answer, and I feel like a big stupid idiot. It feels like it should be like 4:30 right now, and not like 10 till 11.
We were giving Tyler a hard time about asking you questions during your, whatever it's called. And he was like, well, I think she handled it very professionally. I think I helped her out.
It's alright. It went okay. It just stressed me out. And really, it's just that the definition of a tangent line and a secant line, like, it's really true. Those were still tangent lines and secant lines. It's just, we have to get into a very much more complex definition to talk about. That it's really true. A secant line, it still went through 2 points, but it can go through more than 2 points. It's so weird. It's just, anyway, it's alright. Negative 2, right? And we got x equals 1/3. Yesterday, Friday, you got to leave that because it's imaginary. But today you don't get to leave it. You have to solve it, which means you can subtract 27 over. You can divide by 3 and get x squared equals negative 9. So what happens when you take the square root of negative 9? X equals plus or minus 3i. Your calculator will say error, except for probably Jake's cheating Casio. It probably says 3i. Notice. Notice there are 4 answers, 2 real and 2 imaginary. If they wanted you to write this out as the factors, you just do the opposite. So if negative 2 is the 0, it's x plus 2. If 1/3 is the 0, it's x minus 1/3. And for 3i and negative 3i, you just do the opposite. X minus 3i and x plus 3i. Those are the factors. The others are the zeros. Cheating. Those are cheating calculators. I know. But they used to not be allowed. I used to check those calculators before tests, and I would be like, nope, you can't use it. And both of yours would have been on the nope, you can't use it file. Just to vary the reason you get to use it now, so you can think.
What do you do?
He just argued that if I gave a no calculator portion of the test and a calculator portion of the test, which I do into calculus a lot, that on the calculator portion, as long as he showed his work, he should be able to use his calculator if he was more comfortable with it. And I agreed that when I separate calculator and no calculator, when I don't separate calculator and no calculator, I probably still should not use it. How do you argue with Joseph Barry, who never talked ever? I know. He never talked to me. All right. Real quick, let's do Descartes' full sign off.
Okay.
What does that mean?
That there's 0.
And so then if I plug a negative in, all even exponents stay the same, constants stay the same. Yeah, we know by the fundamental theorem of algebra there has to be 4 zeros. None of them are positive, none of them are negative. They're I always like to say I don't like you because it's fun to say. But I really, U substitution is nice in some ways, but sometimes it's extra work. So for me, this looks like a quadratic except for it's x to the fourth instead of x squared. So instead of doing U substitution, I just ask myself, instead of putting x and x here, what could I put here that when I multiply together would give me x to the fourth? X squared and x squared. If you just take that one extra step, you don't need U. You don't need U. And then I do the same normal factoring. What multiplies to give me 4 that adds to give me 5? Can I now solve both of those? Yes, I can say x squared equals negative 4, x equals plus or minus 2i.
We don't have to have the x in the middle form.
Say that again.
Like, wouldn't it be 4x or no 6?
Right, it's x squared times x squared would give you that x to the fourth. See what I'm saying?
Well, I'm used to like the middle two being like 4x.
Right, so our middle term would be x squared now because the middle term is x squared. If you wanted to, you could say that u equals x squared, and you could rewrite this as u squared plus 5u plus 4. Remember the u substitution from algebra 2? I find it extra work because you still have to factor this into u plus 1 and u plus 4. And you can say u equals negative 1 and u equals negative 4. But I don't care what u is, I care what x is. So you have to go back and plug in your x and say x squared equals negative 1, x squared equals negative 4, and you still get the same answers. Some people really like u. I can go without it. It's really fun. It's my favorite thing to do is talk about u. And in calculus, we talk about f of u, which is even more exciting. So.
When is that?
We've done it once already, but next semester we talk about f of u a lot. So.
Hey, just a reminder, we are dipping ice cream sundaes in the outdoor concession stand. After lunch, come on out and enjoy. Thank you.
These are your homework problems. I believe the first two, they just tell you what zeros there are and you say what's missing. So 12 and 15 I think are super easy. 24 and 27 are like the ones where you have to find the extra zeros. They give you one imaginary, you have to do synthetic division. One of them is just an I, one of them has an addition. So just like our notes. And then 36 and 37, I think one of those is factorable, probably 36. 37, I'm telling you to pick zeros between negative 5 and 5 from your PRC. Okay? Oh, I don't know. You don't need to do that.
Here's about this episode. Please let me Taylor Patton, Alexis Arian, Evan Hendrickson, Jace Robinson,
Oh my gosh.
Ashley Rashawn, Matt Parker, Dylan Cannon, and Brady Robinson.
Don't forget your ice cream.